When I posted my first video about Mount Ibu in Indonesia, one of you asked why the lava didn't just spill out sideways instead of going upwards during an eruption, and that got me thinking. There are different types of eruptions, but what determines whether an eruption will be mild and relatively calm or explosive and full of hot lava? It turns out there's an easy answer. You just have to look at the right place. You see, whether a volcano erupts explosively or calmly depends on the viscosity or thickness of its lava. To see why, let's take a look at Mount Vesuvius, which famously destroyed the Roman city of Pompeii in 79 AD. The lava from this eruption is classified as high-viscosity lava. High-viscosity lava is similar to honey in that it's thick and slow-moving. If we were to recreate this lava flow using honey, we can see that it doesn't travel very far before coming to a stop. Now let's make our honey flow down a slope to simulate flowing lava. You'll notice that even with gravity working against it, the lava doesn't travel very far. Because it's so thick, it piles up and spills over to the sides. This type of eruption is called a lava flow and is the most common type of eruption. They're generally not very dangerous unless you happen to be standing directly in front of the lava. Let's compare this to another volcano, Mount St. Helens in Washington State. In 1980, this volcano erupted explosively, sending ash and debris miles into the air. The lava from this eruption is called low-viscosity lava. Low-viscosity lava is similar to water in that it's runny and flows easily. If we try to recreate this using water, you can see that it flows much farther than the high-viscosity lava. And if we were to add a slope to our water flow, we can see that it travels extremely quickly and doesn't pile up very much. Water is less dense than lava, so this isn't exactly how lava behaves, but it gives you the idea. Low-viscosity lava can travel great distances very quickly, and because it flows so easily, pressure can build up underneath it until the pressure is greater than the weight of the lava column itself. At that point, the lava erupts explosively out of the top of the volcano like a shaken bottle of soda. So to answer the question from the beginning of the video, the reason that Mount Ibu's lava flows upwards during an eruption is because it has low viscosity, just like water. During a mild eruption, the lava piles up around the vent or opening of the volcano. As more lava is created, the pressure beneath the lava increases. Eventually, the pressure is great enough to overcome the weight of the lava and it erupts upwards. When this happens, it's a bit like popping the top off a shaken bottle of soda. However, if the lava were to spill out sideways, like what happens with high-viscosity lava, then gravity would work against the upward building pressure. In other words, it would be hard for pressure to build up under these circumstances. So low-viscosity lava erupts explosively upwards, while high-viscosity lava flows passively sideways. There are some other factors that affect how explosively a volcano erupts, such as the amount of gas in the magma and the shape of the volcano itself. But the main factor that determines the explosiveness of an eruption is the same as the factor that determines how your honey flows. So next time you're enjoying a nice pot of honey, take a moment to think about all the ways it's similar to volcanic lava. I hope you enjoyed learning about volcanoes and lava. If you want to learn more about volcanoes, you can watch this video. Thank you for watching and see you next time.